let's talk about this. Right? What is complex number? Right? Now, this Venn diagram, I like it a lot, okay? Because it's so-called, in a way, makes it very clear-cut, like what you have learned all this while, right? Since when you are much younger. So let's go back all the ways, all the way back when you were much younger. All right? The number that only matters to you will be what we call counting numbers, right? I got 1 sweet, he got 2 sweets, John got 5 sweets. Counting numbers are also known as natural numbers, right? So you learn in Sec 1, you understand that I have how many numbers? These are for counting purpose, natural numbers. Okay? Then, when we grow a little bit older, we understand the meaning of 0. Okay, what they call the whole numbers. Alright, so whole number including 0. Then after that, you go to secondary school, you start to understand there's these numbers, the idea called negative numbers. Alright, which the whole set then become what we come to know as integer. Okay, so from knowing how to measure things like I only have 1 sweet, he got 2 sweets, to the fact that I can even visualize, oh, I have negative 2 sweets. Why do I have negative 2 sweets? Well, because I borrowed 2 sweets from you, so now I have negative. Right, makes a bit of sense, right? Now, then as we grow older some more, right, then we understand that, well, life is not just about integer. I'm not like 1 meter or 2 meter tall, right? Well, somewhere in between. So that's when we start to learn fractions and decimal numbers. Okay? So fractions and decimal numbers are what we call rational numbers. Fractions and decimal numbers are called rational numbers. Okay? So rational numbers are numbers that can be expressed as fractions, and then now we can measure things like I'm 1.24 meter, right? I'm something about 5.64, and all the decimal comes in. And then at the same time, we start to understand what we call irrational number when we're in Sec 3. Right? In Sec 3, that time, we start to learn this idea called surds. Irrational numbers are numbers like square root 2 that cannot have a there's definite pattern. Okay? So that is when we start to realize that we can calculate things like the diagonal of a square. Okay? It used to be that we can't. Now we can, because it is square root 2. It's an irrational number. So this whole set of numbers that is called rational, irrational numbers, all the numbers in the world that you have learned so far since you were much younger until now, are called real numbers. Okay? So the whole universe of numbers, all the way until probably for some of you today, alright, is all real numbers. You're operating inside this set. Okay? So after today, we're going to expand our knowledge of number to include this idea called complex number. So as you can see, all the numbers in the world that we know so far is a subset of a complex number. Okay? Complex number is the overarching kind of a set there. So far so good? Okay? So meaning to say what is more important, well, it's literally just the simplified diagram. That our real number is a subset of a complex number. In other words, every single real number is a type of complex number. You probably want to understand it as a female is a subset of a human. That kind of, every female is a human. That kind of feel. Okay, so every real number is a kind of complex number. So, first of all, what the heck is this complex number? Well, the complex number is basically this idea called I, where I is defined as the square root of negative 1. Right? Now, this is a little bit mind-boggling if you ask me, because all this while you are told that you cannot square root a negative number. So, well, now you can. You call it I, the square root of negative 1. Now, let's think about this number a little bit. What does I really mean? Right? I literally means imaginary. Some people like to think it's idiotic, but it's imaginary. Right? I for imaginary. So, it's a number that is exists in your imagination. Now let's think about it. This number, you cannot visualize. Seriously, you can't visualize. I mean, you see, you can visualize number 1, right? Because you got 1 sweet, 2 sweet, 3 sweet. You can visualize the number 0 because the moment I eat the sweet, got no more sweet, 0. I can visualize negative number because you can think in terms of I owe you money. It's more abstract already, right? You can visualize every single number on the number line, including square root 2. Well, square root 2 is somewhere between here. Right? Somewhere there. So you do know where all these numbers belong, and you can visualize. In fact, even very abstract idea like irrational numbers, square root 2, you can also visualize because they say that, Mr. Ang, this is what square root 2 looks like. But I is something really interesting. You can't see it. You can't understand it. Basically, it's just like, okay, it's just something someone said. Okay? So, this idea called I, right? Imaginary number. So the next question that usually students will have is, why do we need this? which is a fantastic question, I would say. Okay, I actually asked my teacher last time. My teacher told me this, which is a not very convincing answer. I'm going to share it with you anyway. So his answer to me was like, oh, okay, so you learn this so that you can solve this equation. You know, because it used to be that this can't be solved. So now, x squared is equal to minus 1 is solvable because x is now plus minus the square root of minus 1, which is plus minus I. Okay. So then it's like, why do we need to solve this? If it's unsolvable, then so be it, right? So somewhere along the way, I was fortunate enough that I come across another teacher, probably somewhere in uni. So he gave us a better answer to this question, like why do we learn this? As I was describing you the story, right? Every stage of your life, probably sound a bit, but every stage of human development, the moment we open our ideas to new numbers, we can do more things. Agree? Like when you were much younger, you only know numbers like 1, 2, 3, 4. The moment you are able to accept decimal numbers, then you can measure things like your height, your weight and stuff. And the moment you accept your idea to this thing called irrational number, then you can measure things like this. Correct? Now this is quite a recent development. No? It's basically about a few thousand years ago. This is when this happened, because that was because of Pythagoras' theorem. Before Pythagoras, nobody knows how to measure this. Right? So because of Pythagoras, then this makes sense, and then everybody can do that. So you want to think of complex number as a tool like this as well. Right? A real number, yes, it helps you with many, many things, but you are able to expand your idea to accept this thing exists. Then you can even do even more. Okay? But that still sounds very airy-fairy, right? So those of you who has friends in poly or what, especially those electronic engineering, as far as I know, they do have a lot of complex number in it. Just that they don't call it I, they call it J. But anyway, they're the same idea. So let's get to know this I, our new friend, a little bit more in detail. Okay, so that's the definition. All right, it's defined by human. This is not in nature, it's invented. In nature will be like numbers like pi. This is in nature. Nobody invented it, it's God. Okay? But this is invented by human being. Understand? And my prof told me it's invented by two guys who invented it for the sake of a game. I don't know what game they're playing, must be very bored there. Okay, so they invented it, and then some mathematician saw it and go like, hey, there's a good application to this. So they started using it. Okay? So, and then now we started learning it. Okay? So if I is a square root of minus 1, then I square is minus 1. Get used to it. Alright? We were told that a perfect square can never be negative. Well, it can, if it's I. Okay? Now, I cube is I square times I. So I square is minus 1. So minus 1 times I is minus I. I4 is I square times I square. So it's minus 1 times minus 1. You go back to 1. And you probably guess what is I5, right? Because I5 will be I4 times I, which is 1 times I. Go back to I again. So the cycle repeats. Just get used to this. Okay? So it's a bit weird. Now, a complex number, the general format of a complex number looks like this. Okay? We usually denote a complex number by the letter Z. Alright? So Z equal to X plus IY. The X is what we call the real part. Okay? The Y is what we call the imaginary part. Alright? So the real part of Z is denoted by this, RE bracket Z. The imaginary part of Z is denoted by this notation called IM bracket Z. Okay? Not too hard. Let's try. So the idea is this, right? If I have Z equal to 3 plus 4I, then we say that the real part of Z is 3. The imaginary part of Z is 4. That's it. Yeah, sometimes you see in your calculator when you use the quadratic solver, right? Yep, that's it. So far so good. Now, sometimes we have Z equals to 3. Then we say that, well, this is a real number. Because a real number has got 0 imaginary part. Follow? So now you probably understand why a real number is a subset of a complex number. Because a real number literally is just 3 plus 0i. Okay? Okay? So it's called a real number. Alright, similarly, we can have a situation whereby we have 0 plus 4i. This is what we call a purely imaginary number. Okay? So all the numbers in the world is either this or this or this. In fact, the and the overarching set is called complex number. Now you probably understand. So a real number is just a subset of it. All right, it's a special type of complex number whereby the imaginary part is 0. So far so good? Okay, all right, not too hard, right? Sounds quite easy, right? Let's move along, right? Like all the time, whenever we learn a new number, we must learn how to deal with it. Okay, so what do we need to deal with it? Well, the 4 basic operations on numbers, okay? So just like when you're in primary school. So some of you haven't learned complex number at all right? So I'm going to give you a quick quiz. And I want you to just think about it. It's not difficult. And I just want you to guess, okay? The truth is that you haven't learned this. So I just want some of you to guess. Those of you who learned it, never mind, I know you know, okay? Those of you who haven't learned it, I just want you to guess. I have 2 complex numbers here, W and Z. Say I want to add W to Z. What do you think the answer is? Have you learned it before? What do you guess? 4 plus 6i. Correct. That's it. Is it very difficult? Not really, right? Okay, now let's say I want to do a subtraction for my complex number. Again, you never learned it before, right? Okay, so what do you think the answer is? Just guess. Negative 2 minus minus what? Minus 2 lah. Correct. This one, 1 minus 3, and then 2 minus 4. So far so good? So, do you really need to be taught how to add and subtract or not? I don't think so, right? Just take the real, add with the real, the imaginary, add with the imaginary, right? The real minus the real, the imaginary minus the imaginary. You get this answer. So this is how we add and subtract complex number. Super easy, okay? Nobody needs to talk too much about it. You probably can go, oh, actually, that's super easy. The next thing that we want to learn is, of course, 2 more. All right, so we come across addition, subtraction now, right? So the next thing I want to come across is, of course, the idea called multiplication and division. 4 operations, okay? So multiplication and division, but before we go into that, we need to talk about this idea called the conjugate. Now, you've probably heard of this term before, right? Conjugate. You learn it in Sec 3, or rather you come across it the first time in Sec 3 when you learn it in certs. Yeah, okay? You learn it in certs. Now, let's go back all the way back to certs, right? Now, if I have a cert like this, square root 5 minus square root 3. And we say that the conjugate will be square root 5 plus square root 3. Alright? Conjugate is not the negative. Okay? It's just merely the middle sign change from minus to plus, or plus to minus. So we say that this is the conjugate of that, that's the conjugate of this. Alright? Now, in certs, why do we learn conjugate? We learn it for one purpose. And that is, yes, exactly, right? In certs, they somehow don't like this answer because they say that this doesn't make sense. So they want you to rationalize it. And the way to rationalize it is to multiply by the conjugate to the top and to the bottom. All right? Then you ask, yeah, I learned this before. And this one, the overall idea behind this, or rather the engine driving this to make sense, is actually from something rather simple, right? A minus b times a plus b is a squared minus b squared. We all know this. Agree? So you see the denominator, what will happen? Right? We have this minus that, and times this plus this, so we're going to get a 5 minus 3. Okay? And the idea behind rationalizing is that after you rationalize, it becomes a real number. No, rather it becomes a non-cert. Okay? Now all this you know since Sec 3. Okay? So what we're going to learn for conjugate in complex number is rather similar. In fact, very, very similar. Now, the idea of conjugate in complex number is so important and so useful to the point that they have their own notation. Okay? So if I have a z that is, say, let's use the number 3 plus 4i, for example. The conjugate of this complex number is what we call z star. So every time you see a z star, it means it's the conjugate of z. Okay? So the conjugate of z will be 3 minus 4i. See the parallel? Again, please pay attention. The z star is not the negative z. Okay? The complex number, the conjugate is not the negative of the complex number. So far, so good. Okay. Now, then you ask, okay, so what's so special about this, right? Like, well, what's so special about this will be when you multiply two pair of conjugates together, like one pair of conjugate together, z and z star. Something special happened, really. 3 plus 4i multiplied by 3 minus 4i. It's a bit like what we are doing here for rationalizing, isn't it? Something special happened. So what is that something special happening? Well, of course, it's based on that formula that we knew since we were young. So we said that, hey, this is the a plus b times a minus b. So the answer obviously must still be the same, right? 3 square, which is the a square, minus the b square. But the something special happens here when we try to pay attention to this. And we have 9 minus 16i squared. And we then understand I squared is a number because I is the square root of minus 1. So I squared must be minus 1. So if it were to be minus 1, it becomes plus 16. And this whole thing becomes 25. In other words, when you have, in general, a complex number, say, x plus iy, then the z star will be simply x minus iy. And when you multiply the z to the z star, you are going to get x squared plus y squared. So it's like, oh shoot, everything suddenly becomes a bit haywire. Because all this while you learn that only a squared minus b squared can be factorized. Alright, suddenly this is like x squared plus y squared, it is also factorizable. But only in complex number space. Or in complex number world, if you like. So far so good? So this is a special result, and trust me, this result is super duper useful and important. Okay? So it's right here. Right? Z times Z star is this. I hope you understand what I just told you. This is important. You probably need to remember. Okay? Now the next one, if you take a pair of conjugates and you add them together, something special happened also. Now this is not too hard. Let's do it quickly. So if Z is x plus iy, alright, then Z star must be x minus iy. And if you add them together, you can tell that these two will cancel away, you get 2x. Right? And what is 2x? 2x is 2 times the real part. 2 times the real part of Z. Again, it becomes a real number. So far so good? Okay. Now, same thing for the subtraction. If you try, Z equals to x plus iy. Z star will be equal to x minus iy. So if you subtract this together, you can see that x and x will cancel with each other, right? Then this becomes 2iy, or yi, or whichever way. So z minus z star is 2 times the imaginary part of z. So far so good? Okay. Now, like I said, these are called important results. Okay, but we probably will not be using these too much today, but we will be coming back to this box in the near future. Okay, just so you know, because conjugate is very important idea in complex number. We'll be using it later. Okay, but the idea is, well, you want to know it, okay, what is a conjugate? Now, some people get a little bit confused by conjugate. Let me explain, okay? And the idea is this. If z is equal to minus 3 minus 2i, what is my z star? It should be minus 3 plus 2i. Okay? So it's not a negative. Just be very clear. Right? Sometimes you have this. The teacher may just write your complex number in a way like this. Okay? So what is the z star? So those people who are thinking, oh, I just changed the sign in the middle, then that will be wrong. You don't change the sign in the middle. You change the sign of I. You follow? Because it's always real plus the I. So sometimes they arrange it this way. It's just to trick you or to fool you. Right? So you don't be fooled. The conjugate is this. Okay? And I mean, sometimes it's quite hard to tell, but the moment you arrange it back to the normal sense, you probably can see the conjugate thing works out much easier. Okay? It's just that sometimes they arrange it this way. Now, similarly, if I have a number that is called 3, then what is the conjugate? 3. You must be confident. Why? Because 3 is 3 plus 0i. And the conjugate will be 3 minus 0i. But nobody really cares about the 0i. Similarly, if I have a complex number, say 3i, then what is my conjugate? Minus 3i. So you want to know your conjugate really well. Okay, a conjugate is not the negative. I have been saying this like I don't know how many times by now. Okay, so it's very important. right, that you understand the idea behind conjugate. So far so good? Okay. Now the next thing, well actually we haven't really touched on multiplication, right? We just talk about conjugate. And that's because it's something to do with multiplication and something special happens when you multiply a pair of conjugate. Now what if you multiply something that is not a pair of conjugate? Nothing special happened, the truth is. Okay, so let me show you quickly. If I have W is equal to 1 plus I, and I have Z equals to 2 plus 3I, for example, and if I want WZ is equal to this times this, again, those of you who never learn complex number ever in your life, what do you think you do? Not really cross multiply, it's called the eyebrow, eye back multiply, the rainbow multiplying, right? Like this. And yes, absolutely right. Okay, not difficult, just do it. 1 times 2, 2. This one times this one, 3i. This one times this gives you 2i. Now, this is probably the most new thing, and that is 3i squared. 3i squared is minus 3. Be careful with the I square. Well, we probably memorized it by now, right? I squared is minus 1. Just get used to it. Okay, so a lot of things to get used to. So far, so good? Not very hard, right? Let me tell you a good news. This can be even easier and faster because you have your GC. And your GC can handle this. Okay? All you need to do is to key in everything you see here. Okay? 1 plus I. Where to find the I? Well, the I is the little I in blue above your decimal point button. Can you see that? Okay, so you go to second function, decimal point. So there's a 1 plus I there. Okay, close bracket, open bracket, 2 plus 3i. And then you close again, press enter. That is the answer that you get there. Okay? Now, using GC is cool, it's fast, and it's probably the safest. Agree? But do take note, you don't really use this 100% of the time. For a couple of reasons. Sometimes they are inserts, they want the answer inserts, then you can't use this because it won't be exact. Okay? Other times is you don't really get 1, you get A. Then you have to do the expansion yourself anyway. So you better know how to do this. So far so good? Okay, so we talk about addition, subtraction, conjugate, multiplication. What's the last thing to do? Division, right? Okay, great. So let's talk about division. If I want to take my W divide by Z, so that will be 1 plus I divided by 2 plus 3I. How do I do that? Now, if you use the concept of surds to help you understand. For example, I have a surd. This is lame. Okay, hold on. Okay, how do I sort this out? The truth is you can't do a long division for this, right? And the best thing you do to sort this out will be, not calculator, yeah, rationalize it so that you can try to see a fraction, right? What minus what or what plus what. So same thing here, when you're trying to divide a pair of complex number like this, okay, the next best thing you can do, in fact, you can't really divide or do a long division, so what you can do is you rationalize it. Multiply to the top, multiply to the bottom, and to the bottom, let's try to get used to it. You're going to get 4 plus 9. Are we okay? Think again. Possible? Can map that. How I get the 4, how I get the 9, and it's positive, not negative. Okay? How about the top? Well, the top is a bit more troublesome, but it's not hard to do, right? It's like I'm going to have a 2 minus 3i plus 2i minus 3i squared. Do you see that? Minus 3i squared becomes plus 3. So my final answer will be over 13. What is that? 5 minus I. Okay? And if you want to see the real part and the imaginary part, that will be 5 over 13 minus 1 over 13i. That's the real, that's the imaginary of this answer. Okay? Again, we could have used our GC for this purpose, right? So we have open bracket 1 plus I, and then we close the bracket, we divide by, what is that? 2 plus 3i. And then we close the bracket. Then we're going to get, well, this number. Not quite the same. So you can change it to fraction. If it's not a surd, your GC can still manage. So not too bad. Are we all cool? Okay. All right, so I won't say short lecture, but I will say in this short period of time, you come to know this new idea called complex number. Suddenly your number universe expanded by quite a bit. You also learn how to deal with it, how it looks like, how to add, subtract, multiply, and divide, and also know the twin brother that is different but same. right? What we call conjugate. So far, so good? Okay. Then you say, what is this for, right? Well, there are some important properties that we need to come to get used to them as well. Okay, so these important properties that we talk about, well, is important, but like I said, we probably will not be using too much of this today. We will be coming back to this whole table one time. But I do want to talk a bit about it so that you become a little bit familiar. Okay, familiar in the sense that you are not scared of things like this. Okay, what I mean is, actually everything is quite easy to prove. For example, like this one, right? The conjugate of Z conjugate is Z itself. It sounds really quite scary to imagine why, right? The idea is not difficult. So imagine you let Z be equal to A plus BI. Then we will have Z star to be A minus BI. So Z star will be A minus BI star. And A minus BI star will be A plus BI, which will be Z. So this property is not difficult to understand. All right. Similarly for the rest, really, they are all quite so-called provable. All right. Now, why I want to even talk about this is because in times, you see, nobody really memorized every single one of this. And trust me, this list is not exhaustive. There are some more. It's just that they are all very obscure sometimes. You don't even need to use it often, so nobody is going to memorize this. But sometimes when they're solving question, right, then you come to wonder, hey, is this true or not? Z square conjugate, is it the same as Z conjugate square? Because maybe you need that to help you solve something else. Correct? Then you realize that I didn't memorize. Then how? Can you check? Yes, you can. How to check? This is one way, and this is the whole reason why I want to go through a few, so that you have the sense that if I need to think about whether is it true, I can sort it out myself. The easiest way is you use numbers, but you know that numbers sometimes by luck it works, so you have to use letters to be safer. So let's say this one, all right? Somehow I don't know. I don't know whether does it work or not. So can I try to show it, right? The answer is yes. So again, the trick will be this. So let Z equals to A plus BI, correct? And if you have Z star, Z square becomes just expand, right? So you have A square plus 2ABI minus B square. Okay? So this is Z square. Now you may want to arrange it so that the real part is here, the imaginary part is at the back. So this is your Z square. Now what is Z square star? Well, Z square star would then be A square minus B square minus 2ABI. Make sense? So this is your Z square star. Now Z square star is Z star square. Is it true or not? Okay, so you check. This is actually the square of A minus BI. A minus BI square. Agree? Correct? Because you are going to have a B square at the back, so it's a minus B square and then a 2AB. Okay? So this then becomes your Z star whole thing square. Now, if it works for square, it should work for cube. And therefore, suddenly, you should have this formula in a way. Now, you see, the thing about our syllabus is that they won't ask you to prove. Hey, prove this. No, they won't. It's just that sometimes we may need to know this in order to help us solve something else. Okay? So it is useful to know how to think about it or how to try to show it. Understand what I'm talking about? Can? Okay? Here to here? Okay, you see, if you expand, you're going to get A square minus 2ABI, which is this one, and then plus BI square. So BI square is minus B square. Okay?